today. Introducing you guys to Newton's second law, the idea that the net force provides an acceleration. So F net equals ma, or the acceleration is equal to the net force divided by the mass. We did 5 examples. Some of them had, in just different orientations. Some of them we're talking about in and out of the page, or a force acting to the right, or a net force acting to the right, or we had forces that would add together to give us a net force. We had forces then on the Batmobile that were acting in opposite directions. We connected that to the idea of G-forces, and then I gave you this page to take a look at. I've got answers to this whole page. Before I provide you with the answers, are there comments, questions, concerns about how this stuff is done, or should I just show you the results and let the chips fall where they may? Yeah. You do on these bottom two? Let's do it. Sure, let's do them. Before I show the answers, let's do it. So question 2 said to use the information given for each diagram to fill in all of the missing blanks. And so we've got this information here. We're told that the mass of the object is 40 kilograms. We're told that there's a 4 meter per second squared acceleration to the right, and that there's an applied force to the right of 200 newtons. We want to fill in Fn, Fg, and the force of friction. Unless we're told otherwise, presumably this thing's, there's an Fn there, so this thing's sitting on the ground. And these two, the arrows are drawn the same, and for an object that's just sitting on the ground, these two are going to be equal. Fn and Fg is always a safe place to start. Fg is going to be found by doing what? How do we calculate the force of gravity on an object? Careful. Fg is, well, we're going to be really careful with our definitions. Fg is weight. So we're going to take the mass and we're going to multiply it by the acceleration due to gravity. So 40 times 9.8 is what? I got 392. And then Fg is going to equal Fn because presumably this thing's not accelerating up and down. So those two are going to be equal and opposite, and that gives us the start of this. Now we just have to go back and find the force of friction, because that's the only other thing we don't know. We know that the applied force is acting to the right, friction's acting to the left. And so each one of these is going to start with F net equals ma. What are the and because we've got forces acting in opposite directions, we have to call one of them positive, one of them negative. So which way do you want to call positive? Which way do you want to call negative? To the right is positive. Okay. If to the right is positive, when we plug these two forces, because it's the thing's moving to the right, so when we're talking about F net, we need to bring in all of the forces that are acting left or right. So if to the right is positive, we're going to have the applied force Fa minus the force of friction is going to equal the mass times the acceleration, and now we can just plug all that in. Fa is 200 minus the force of friction is what we're looking for, is going to equal the mass, which is 40 times A, which is 4. So we're going to get 200 minus the force of friction is going to equal 4 times 4 is 16, and the other 0 is 160. So then what does the force of friction have to be? Sorry? I thought someone said it. 200 minus what is 160? Thank you. One brave soul. So the force of friction has to be 40 newtons. And that's the second last question done. That's how we go ahead and solve this thing. Yeah, you wanted the very, very last one done. You've got a 500 Newton force up, a normal force, 125 back, no Fg, no M, no A. So let's figure all of this out. Given the fact that we have a 500 Newton normal force, where should we, the first thing we can find relatively easily is what? Fg. Fg is going to be 500. Equal to and opposite Fn. So then if Fg is 500, what's the mass going to be? Fg is equal to mg. So then to find m, I'm just going to divide both sides by g. So mass is going to be the force of gravity divided by the acceleration due to gravity. So 500 divided by 9.8, it's going to be 51.02. And now we can go ahead and find the acceleration. F net equals ma. What are the forces acting in the direction of motion of our object? There's only one force that could be acting in the direction of motion. Sorry, Raina? What did you say? You were right last time you said something. Be brave. Say the thing. You're saying drag. Yeah, except it's not called drag on this picture. It's called force of friction. But yeah, this guy. This is if these two are equal, presumably this block is just moving left to right. If there's friction acting, we know this object is actually moving which way? Friction opposes motion. So if friction is to the left, which way is this block moving? Moving to the right. If there's an unbalanced friction force, friction always opposes motion. So it has to be moving to the right. So we're going to have the force of friction is going to equal the mass times the acceleration. So it's going to be 125 equals 51.02 A. That's going to give us a value of A of 2.45 meters per second squared, and you're done. Okay, there you go. Does that make sense? Are you sure? You look pained. You look like you're in pain. Yeah, an emotional pain? I don't know. Okay, cognitive pain. I saw another hand. Who's the other? Sire. Well, if you move, think about it at the granular level there. If you put an object on the surface and then move the surface, what does the block want to do? It wants to stay in place. And you're pulling the desk to the right. So friction's opposing. Moving the surface to the right is the same thing as moving the object to the left. Like in isolation, that's effectively what you're doing. So friction is going to oppose the desired motion of the block. You have to isolate what you're actually talking about moving, and then it becomes a lot clearer. Well, it becomes less muddy. It doesn't necessarily get clearer. Okay, here are the answers to the rest of these questions. These are the top ones. If you have no questions because you didn't do them, well, I would encourage you. The only way you're going to wrap your head around this stuff is by practicing it. So this one, first question, just wanted you to find the net force everywhere, magnitude and direction. So there's no net force, 250 up, 175 to the right, 60 to the right, 100 to the right, 55 to the left. Comments, questions, concerns on any of those? Once, twice, thrice, sold. Okay, cool. And then there's these 6, wants to fill in the blanks. So the acceleration here was 10. Normal force was 117.6. Gravity is 117.6. Everything's balanced, so there's no acceleration. 392, 392, and 40. 78.4 and 10.2. 392, 392, and 40. And then 500, 51.02, and 2.45. Any other questions on any of those? Anyone would like me to go over? Yeah. It's really hard for you to read any of the numbers if I do that. Is there something you want to see specifically up top? I move it while you're taking a picture. I guess I just make it blurry. Okay. So how do we feel about this stuff? Sorry, I shouldn't have asked the question if I didn't want the response. Okay. Here's what I'm going to get you guys to do. Flip to this page. I want you guys, this is a unit. It's different from what we did. It's different than what we did in kinematics. It's brand new. I want you to spend some time figuring out this stuff, wrapping your head around it cognitively. So I'm going to assign 5 questions here, and I'm going to give you some time to, or maybe I should assign all the questions on here. Give you some time to work on these things. Do I want to give you the whole thing? Okay. So here, yes, I'm going to give you the whole class to work on this, because tomorrow's lesson is short. Here you go. I want you to do the following questions: 1, 3, 5, 7, and 9. And I want you to write down the following numbers down here on the bottom: 3,400, 540, 4.8 times 10 to the 4, 1,800, 0.88, 52, 350, 150, 260, 5.4 times 10 to the 5, and 1,800 again. Those are the answers in no particular order to all of the questions above, and I'm only assigning 1, 3, 5, 7, and 9. Once you've written down those numbers, I'd like you to flip the page there, or to there. And I'm assigning this page as well. I'm giving you an hour to work. I'm going to give you an hour's worth of work. I want you this whole page. Each one of them has this page has the answers to the questions. And because I know it's going to snag someone, I'm going to define this word pachyderm for you. What's a pachyderm, anybody? Anybody know what a pachyderm is? Nobody knows what pachyderm is? You guys need to watch some more Disney movies. Pachyderm's an elephant. Clearly none of you have seen the movie Dumbo. And you should know what a pachyderm is. Maybe it's been a long time since you've seen Dumbo. None of you have watched Dumbo recently enough. So that's what you're working on today. I got 12 questions there. I want you to practice it. Feel free to use the whiteboards. I'm here to help. I'll walk around as needed. And then tomorrow we'll look at, it's Friday, shorter block. We'll look at Newton's third law. And then we'll talk about universal gravitation on Monday. Cool. Okay. That's the plan for you guys for today. Let me know how I can assist you. Put your phones away on your mark and say giver.